सर आप ही भी कह रहे कि आप को भी भेज दिया करो।
अच्छा, नेक्स्ट इज
सर वैसे एक
क्वेश्चन
बात है, सर
जी।
लोग आपका वो मैसेज करते हैं या नहीं, देखते हैं, कोई अभी तक आया है कोई या नहीं?
हाँ, आ रहे हैं अभी।
वाओ।
ओके, नेक्स्ट पूछे पढ़े क्वेश्चन नंबर 4।
4 shows a speed time graph for a car traveling on a straight horizontal road. Describe the motion of the car.
तो हाउ कैन यू डिस्क्राइब द मोशन ऑफ कार? ये तो बहुत
T
सिंपल है।
0 to 10 constant acceleration, from
हम्म,
T 10 से लेकर 20 constant speed, 20 से लेकर 24 deceleration for speed which is 0.
स्पीड इज
0 जब तक ना हो जाए,
अच्छा,
constant deceleration.
कांस्टेंट डिसलरेशन। तो यहाँ पे
ऐसे क्वेश्चंस बहुत दफा आ गया अब।
हाँ जी, इस
सर मुझे लगता है कि हमने ये क्वेश्चन किया हुआ है पहले भी ऊपर।
मुझे भी यही लग रहा है, लेकिन एक सेव इसमें लिखा हुआ नहीं कुछ आ रहा। इस तरह के होंगे, काफ़ी किए हुए हमने ना।
हाँ जी।
जस्ट वन। ओके, तो हम पहले लिखते हैं द स्पीड ऑफ द कार इंक्रीजिंग यूनिफॉर्मली। द स्पीड ऑफ द कार of the car increasing the speed of the car increasing uniformly up to till 10 second till 10 second. Yeah, and it 10 second। इसके बाद लिखते हैं from 10 second to 20 second, from second to 20 second the speed becomes constant. The speed becomes constant. The speed becomes constant। ठीक है, स्पीड becomes constant। और उसके बाद हम लिखते हैं then car decelerates then car decelerates uniformly for 4 seconds, for 4 seconds, that is from 20 second to 24 seconds। Next, using figure 7.1, calculate the distance traveled by the car during the 24 second of its motion. Show your working. Ji Abdullah, how we have to find out the distance?
So this under the graph, area under the graph.
Okay, so distance equals area under speed time graph. Distance equals area under speed time graph। अब इसके बाद लिखते हैं distance equals over 2 a plus b into the height। So distance equals 1 by 2, the parallel sides are the upper one and the lower one. 24 and 20 minus 10 becomes 10. तो हम लिखेंगे 24 plus 10 multiply by 16.
270.
270.
272, round up to get to 70.
Okay, 272, that is 270. और आपने एक दफ़ा देख लेना कि उन्होंने ये तो नहीं कहा कि 3 significant figures. If it is not, then you have to write 270 meters. Next is calculate the average speed of the car during its motion. जी क्या करें अब्दुल्ला?
Total distance.
हाँ, एवरेज स्पीड इज टोटल डिस्टेंस ओवर टोटल टाइम. तो हम लिख देते हैं एवरेज स्पीड इक्वल्स टोटल डिस्टेंस ओवर टोटल टाइम. So the average speed equals total distance 272, total time is 24. Check करें.
11.
11. So the
Point
answer point
3333.
333. So this is 11 meters per second. A second car travels speed. It travels the same distance as the first car in the 24 second of the journey. Okay, in the 24 second of the journey. On figure 7.1, draw the speed time graph for the second car. Speed time. Oh, इसमें हमने क्या करना है? यहाँ पे ये एग्जैक्टली हमने क्वेश्चन किया हुआ. ओ, ये तो कोई मिस प्रिंटिंग आई. नहीं नहीं, ये वाला नहीं किया ना हमने. ठीक है. नेक्स्ट यहाँ पे हमने डिस्टेंस कितना रखना है? वी शुड हैव टू टेक डिस्टेंस ऑफ 272 and the time is 24. So the speed is distance over time. Distance is 272, time is 24, and we know that 11.3. So 11.3 पे here is 11 point something 3. तो बच्चे यहाँ से आपने स्ट्रेट लाइन ड्रॉ कर देनी है. आप सही हैं, ये हमने ऑलरेडी किया हुआ है. ये इस बुक में रिपीट हो गया क्वेश्चन. नेक्स्ट इज इसके बाद बच्चे आ जाता है नेक्स्ट क्वेश्चन नंबर 4 पार्ट. पढ़ें अब्दुल्ला?
G. Figure 7.1 shows
ये तो हो गया.
G, the distance, the thinking distance is. So हमने question किया वैसे.
जी जी, ये रिपीट हो रहा है इस बुक में.
The thinking distance is the distance traveled by a car between the time that a hazard is seen and the time that the brakes are applied. The braking distance is the distance traveled while the car slows down to rest. Table shows the different thinking distance for an alert driver when the car travels at different speeds. ये table है, the
The
time.
table of thinking distance and braking distance are given. The definition of
So when
thinking and
thinking
braking are
distance
given.
increases, braking distance also increases.
तो हम लिखेंगे thinking distance is proportional to speed. Thinking distance is proportional to the speed, and the ratio of thinking distance and speed is constant. and the ratio of thinking distance, and speed is constant. Speed is constant. Okay, state what happens to the thinking distance and the braking distance when the driver is tired. So thinking distance क्या हो जाएगा? When the driver is tired. So their reaction time increases, Abdullah. Reaction time increases.
हाँ
So
जी.
thinking distance क्या हो जाएगा? It also increase. And the braking distance, there will be no change in the braking distance, or it remains, आप लिख सकते हैं same. Next question number, define force is a vector quantity. What is meant by the vector quantity?
A quantity that has both magnitude and direction.
The quantity that has the quantity that has magnitude,
And direction.
magnitude and direction. Quantity that has magnitude and direction. Next is the swimmer pushes against the end wall of the pool with his legs. Example of Newton's third law, why the swimmer accelerates away from the end wall. Why the swimmer accelerates against the end walls. जी, ये क्वेश्चन आया अब. The swimmer pushes against the end wall, मतलब वो इस साइड पे फोर्स लगा रहा है. Force exerted by the swimmer. The force exerted by
So इसमें inertia के बारे में बताएंगे ना कि the force exerted by the swimmer, the wall would also exert an equal force in the opposite direction, pushing the swimmer forward.
हम्म, तो जो wall है, the wall exert equal and opposite force in the opposite direction according to the Newton's third law. तो हम कहेंगे the wall explained in term of Newton third why the swimmer accelerates away from the ends of wall. हम लिखते हैं the
So the swimmer exerts the
swimmer
force on the wall. The wall exerts inertia onto the swimmer, causing a
not inertia. मैं लिखता हूँ. The swimmer exert swimmer exerts a force on the wall, on the wall towards towards left, ठीक है, left. So the wall exerts the wall exerts a force on swimmer. The wall exerts
force onto the swimmer.
equal and opposite force on the swimmer. The wall exerts the equal and opposite force on the swimmer. तो इसके बाद लिखते हैं, और इसमें हमने क्या लिखना है, 3 मार्क्स का है. एक तो हमने बता दिया स्विमर का किधर लगा रहा है, equal and opposite force on the swimmer, that is towards right, towards right. ठीक है? अब इसके बाद लिखते हैं these forces are equal. These forces are equal in magnitude but opposite in direction. Opposite in direction. Forces are equal in magnitude but opposite in direction. So resultant force and acting on two different bodies and acting on two different bodies and acting on two different bodies, the object. So resultant force causes acceleration.
जी ठीक है सर.
So the resultant force causes. पढ़ें एक दफा.
The swimmer exerts a force on the wall towards left, so the wall exerts an equal and opposite force on the swimmer, that is towards right. These forces are equal in magnitude but opposite in direction and acting on two different bodies, so resultant force can causes acceleration.
हाँ जी, 3 मार्क्स का इसलिए मैंने थोड़ा सा लेंथी कर दिया. ऑल्दो ठीक है. While swimming, there is a constant forward force on the swimmer. कहते हैं कि there is a constant force on the swimmer. मतलब swimmer जो है वो कहीं इधर जा रहा है करके. So there is a constant forward force on the, and we know that the water exert a backward force which is called the drag force. Yeah. So his speed increases until eventually he reaches a constant speed. This is also a concept like the terminal, but not the terminal velocity. आप कहेंगे constant terminal velocity उस time लिखते हैं when it is falling under the action of gravity. तो हम लिखेंगे the swimmer experiences a backward drag force. The swimmer experiences a backward drag force back, or the drag force increases drag force increases with increase in speed with increase in speed. Eventually the drag force become equals to the forward force. Finally the drag force drag force become equals to the become equals to the forward force. So the resultant force becomes zero. So resultant force become
Zero.
zero. So acceleration is also zero. So acceleration acceleration is also. Any confusion?
No, sir.
Next, question number 6. Figure 2.1 shows a man of mass 80 kg standing in a lift. Lift, man, floor, mansion. The gravitational field strength G is 10. value of G, you have to calculate the weight of the man. Weight equals mg. So this would be m. M is the mass, which is 80 kg tha, multiplied by g. So the answer is 800 Newton. Any opinion?
No, sir.
जी next part B part पढ़े.
The lift accelerates upwards uniformly at this. Calculate the resultant force. So acceleration is A is equal force is equal to mass over area. No,
हाँ, mass over area.
mass of acceleration m over a.
F equals m over a. So F equals m is mass, which is the acceleration is given. 0 0. आंसर देखें क्या होता
T multiplied by 0.500840.
है. So 840 is the resultant force.
G.
840
No, sorry,
is
sorry, 40 सर. वो मैंने
40.
ऊपर वाला ऐड कर लिया था गलती से पहले सेंसर में.
Okay, 40 is the क्या है resultant upward force. The force exerted on the man by the floor of the lift. तो ये लिफ्ट है ना, इस तरह से person is in the lift and exerting a force. So the weight of the man is 800 Newton and the resultant upward force on the man, उसको accelerate कितने से करवा रहे हैं? The upward force is 40. So how much force is needed to the lift? तो 40 उसको accelerate करवाने के लिए 800 to carry the mass of the man. मतलब लिफ्ट ने पर्सन को भी तो उठाया हुआ है ना, 800 तो उसको होल्ड करने के लिए विद इन द लिफ्ट प्लस 40 टू एक्सेलरेट द मैन. तो द टोटल बिकम्स 840. बोला 800 क्यों लगी है फोर्स?
ऊपर से जो वेट था उसका अपना और फिर रिजल्टेंट फोर्स भी लगा.
हाँ, क्योंकि देखें 800 is needed to hold the person within the lift and 40 is needed to accelerate the person. Next is the lift accelerates upward uniformly for 4 seconds and then decelerates uniformly to rest. Okay, क्या करा है पहले? Acceleration is a change in velocity होती है. पहले है the lift accelerates uniformly uh, up to 4 seconds and then decelerates uniformly to rest. To rest का मतलब कि speed become in next 4 seconds. The total distance is 8 meter. जी अब्दुल्ला, this is important graph. अब बचे 4 सेकंड तक. We have to split the graph parts. First is for the first 4 seconds. Next one is अच्छा अब देखें पहले 4 सेकंड में क्या हो रहा है. जी अब्दुल्ला, what is happening in first 4 seconds?
सर acceleration upwards.
Acceleration हो रही है ना, तो
जी
acceleration के लिए distance
वो कर्व
increases
सब.
non-uniformly
जी नॉन यूनिफॉर्मली.
and then अब वो डिसलरेट हो रहा है. सो इट्स अ डिस्टेंस ग्राफ. तो डिस्टेंस के बाद हम शो करेंगे distance decreases finally becomes straight. Okay, here distance increases distance increases non-uniformly. नेक्स्ट बड़े बच्चे
ये भी करना है.
बस ये लास्ट है.
Okay, so an aircraft flies at constant height. Air drag and the force from the aircraft engines pull together produce a force in the aircraft of 36 kilonewtons due north, as shown in this figure.
ओके तो हाउ मेनी फोर्सेस आर एक्टिंग. एयर ड्रैग द फोर्स from the
G.
aircraft engine work together produces a force of on the aircraft is 36,000 newton to north. तो ये पिक्चर नीचे बनी हुई है. 36,000 न्यूटन टूवर्ड्स नॉर्थ, 12 न्यूटन इज टूवर्ड्स क्या होगा ये हमारे पास वेस्ट.
Wind. And you know, west and north. No, east.
नॉर्थ ईस्ट. ठीक है.
G.
नेक्स्ट इज यहाँ
I
पे
scale
बनी
diagram, so
नॉर्थ.
east, south, not yet. West, west.
Okay, draw a scale diagram to show the resultant force acting on the aircraft. You have to find the magnitude of the resultant force and angle direction. तो बच्चे इसमें वन फोर्स दोनों फोर्सेस जो है वो 4 के टेबल में आती हैं. तो हम रखते हैं 1 सेंटीमीटर इक्वल्स
4
4
Newton,
न्यूटन. तो 12 सेंटीमीटर इक्वल्स
3 Newton.
नो नो 3
Ah,
सेंटीमीटर
12
इक्वल्स
Newton.
3 सेंटीमीटर इक्वल्स 12 एंड 9 4 9 सेंटीमीटर इक्वल्स 36 किलो न्यूटन. किलो में 1 सेंटीमीटर रिप्रेजेंटिंग किलो न्यूटन. तो 3 सेंटीमीटर रिप्रेजेंट्स 12 किलो न्यूटन.
Hmm.
तो अब आपने बच्चे एक लाइन ड्रॉ करनी है
So अभी
3
हम फॉर्मूला
सेंटीमीटर
लगा
की.
लें बेशक. फॉर्मूला लगा लें अभी इंस्टेड.
हाँ लेकिन अपने स्केल डायग्राम का है तो आपने वही करना होता है. ठीक है.
ठीक है सर.
लेकिन अभी हम वही लगाएंगे
थैंक यू सर.
ताकि क्रॉस चेक हो जाए. 9 सेंटीमीटर line and you have to find this line with scale, not use the progress. तो यहाँ पे हमारे पास होगा this is the force लिखता हूँ 9 square 9 square plus 3 square. 9 square is 81 I think. हाँ जी 81. 3 square is 9. F equals 90. सेकंड क्या होता है.
सर 9.5 आ रहा है आंसर.
ओके 9.5 क्योंकि हमने स्केल रखा हुआ था ना 9.5 एंड
सर
दिस इज
गलत है लेकिन.
दिस इज 9.5 सेंटीमीटर.
अच्छा सेंटीमीटर से फिर ठीक आ जाएगा.
And we know that this is because we didn't take the actual values of the forces. So 9.5 and we know that 1 centimeter is 4 kilonewton.
जी.
अब चेक करो
एक सेकंड से मैं
36 से ज़्यादा ही आएगा.
38 ही आया आई बिलीव. हाँ
38 किलो.
37.97.
हाँ जी. और now you have to find out the
साइन
angle. और
tan
angle
इनवर्स.
एंगल हम लेंगे कहाँ पे ये इम्पोर्टेंट होता है.
अच्छा ये से join the
ये
angle between the resultant and north. Resultant
north.
कहाँ है?
This this is the resultant. This one
North.
is
तो
the
यहाँ.
north. You have to take angle here.
3 over 9.
So this is theta equals
सर 3 over 9.
verse
18
3 over 9
आंसर आ गया.
over 9.
18.4 आ गया वैसे लेकिन.
So 18.4 18. Okay, describe the acceleration of aircraft is uniform. Uniform acceleration. Describe how a uniform acceleration differs from non-uniform acceleration.
So uniform acceleration has a same change in speed in velocity, and uniform acceleration does not have constant change in
Uh, हाँ हम
acceleration
लिखते हैं
in velocity.
ऐसे लिखते हैं in uniform acceleration in Uniform form acceleration. Uniform acceleration. The change in velocity, the change in velocity in every given interval is the given interval is same, while in non-uniform acceleration, while in non-uniform acceleration, uniform acceleration, non-uniform acceleration, change of velocity, change in velocity in every given time interval, in every given time interval is non-uniform. Oh, is non, हाँ जी, not, not same, or no. Next is the mass of the aircraft is this. Calculate the acceleration. Give the law.
F is equal to M over A. A equal. Sure.
F equals to ma. F is 38,000. M is 60,000 into acceleration. A equals check कर लेना 38 over 60. That's
0.633.
0.6 meters per second square. Confusion?
No, sir.
चलें, काफी है.
G, sir.
Okay. Office.
Allah